Welcome. Today we will be going through question 3 of the Hamilton Olympiad 2018. The diagram shows a regular dodecagon and a square, whose vertices are also vertices of the dodecagon. What is the value of the ratio area of the square to area of the dodecagon? For this problem, I'll be presenting to you two solutions. The first will just involve some simple sine-cosine rules, and the second one will also involve the formula for the area of the triangle half of AB sin C. You can choose either solution, timestamp in the description below, but I would strongly advise to at least take a look at the second solution, because it's useful to know and it's a useful trick going into the Olympiad. So, hint number 1. Remind yourself of SOHCAHTOA and that sin 30 is a half and cos 30 degrees is the square root of 3 divided by 2. It'd also be useful to know sin 45, cos 45, sin 60, cos 60, and sin 90, cos 90. It's not needed in this problem. It could be easily useful for another problem. Hint number 2. Consider the 4 trapezia. What would you like to find out about them? Hint number 3. You know, or you can easily find out, the angles of the trapeziums. Suppose the side length of the dodecagon is x. Then you will know 3 of its side lengths. What is the final side length? Hint number 4. The figure on the left is one of the trapezia from the dodecagon. Try and find out the final side length and also the length of CB. Okay, so sin 30 is a half, which is opposite divided by hypotenuse, so CB divided by AC. So what is side length CB? Similarly, what is side length AB? Hint number 5. What is the area of the trapezium in terms of x? What is the area of the square in terms of x? Simplify the ratio. Solution. Each angle of a regular dodecagon is 10 multiplied by 180 divided by 12, which is 150 degrees. Now, the 4 trapezia are congruent and isosceles, so since the larger angles are 150, the smaller two angles are both 360 minus 300 divided by 2, which is 30 degrees. Now, sin 30 degrees is opposite divided by hypotenuse, which is CB divided by CA, which is a half, and so because half is sin 30, and so CB is CA multiplied by a half, which is x divided by 2. Similarly, cos 30 degrees is AB divided by CA, and cos 30 degrees is the square root of 3 divided by 2, and so AB is x divided by the square root of 3. So the side length of the square is AD, which is 2 multiplied by x divided by the square root of 3, plus x, which is x multiplied by the square root of 3, plus x, which is x multiplied by the square root of 3, plus 1. Now the area of the trapezium is half of A plus B multiplied by the height, which is half x multiplied by the square root of 3 plus 2 multiplied by x divided by 2, which is a quarter multiplied by x squared multiplied by the square root of 3 plus 2. So the area of the square is its side length squared, which is x multiplied by the square root of 3 plus 1 squared, which is x squared plus square root of 3 squared, 3 plus 1 squared, 1 plus 2 multiplied by the square root of 3 multiplied by 1, which is 2 multiplied by the square root of 3, which is all equal to 2x squared multiplied by 2 plus the square root of 3. Now the area of the dodecagon is 4 multiplied by the area of each trapezium plus the area of the square, which is 4 multiplied by a quarter multiplied by x squared multiplied by the square root of 3 plus 2 plus x squared multiplied by 4 plus 2 multiplied by the square root of 3, which all simplifies down to 3x squared multiplied by 2 plus the square root of 3. And so then we find the ratio simplifying down to 2 to 3. We now move on to the second solution, and for this you need to know that the area of the triangle is half multiplied by side length A multiplied by the side length B multiplied by the sine of the angle between them, sine C. Hint number 2. So this is your hint. We've split the dodecagon into 12 congruent isosceles triangles. Solution. So we can split the dodecagon into 12 congruent isosceles triangles, as shown. Now, the angle between the equal sides is 360 divided by 12, which is 30 degrees. Now, let the sides of equal length be r. Then the triangles have area half multiplied by r squared multiplied by sin 30 degrees, which is a quarter of r squared. Now, since there are 12 triangles, the area of the dodecagon is a quarter of r squared multiplied by 12, which is 3r squared. Now, the diagonal of the square has length 2r. So let the square have side length x, and so has area x squared. Then by Pythagoras' theorem, 2x squared equals 2r squared, which is 4r squared. And so the square has area x squared, which is 4r squared divided by 2, which is 2r squared. And so the ratio is 2r squared to 3r squared, which is 2 to 3. Thank you for watching. Please leave a like if you enjoyed this video, and feel free to drop a comment in the comments down below. Goodbye.